So, I took the one lightning talk to introduce myself and the project I have been working on quite some time. Chipster in a nutshell, it's a free open source software for analyzing high throughput data such as NGS. We have a virtual machine release which you can download, or you can use one that's installed on our servers, or at least try that. And it has a graphical user interface for the users. So it's a combination of analysis tools, visualization tools, and then takes care of the workflow, records the analysis history, and you can save and share workflows. It's about 10 years old project, so we have had time to include quite many tools there. There are 140 microarray tools, many of them based on PyConductor, the same amount of NGS tools, and then a little bit for the sequence analysis also. Sorry, forgot to introduce myself, I guess so. So, the name is Petri, I come from Finland. I work in CSC, IT Center for Science. It's a state-owned company taking care of supercomputers for universities in Finland. Let's continue. So this is our user interface, a little bit old school, made in Java. Here is the workflow. This is the raw data, and then there are analysis steps for the data sets that each step has produced. And when you select the data sets, then you see the parameters that were used and then the visualization options for those. So this is a single tab separated file, so there are spreadsheets, feedback, profiles, scatter plots, histograms. And this part is the analysis tools. There are the modules, microarrays, NCS, then analysis tool categories, and then the tools in that category. And then some descriptions about the more help. The source code, of course, because it's open source, you can see what was the code that was used to analyze the data. Okay, a little bit. You can save the work you have done. This is this session. You call it session. Maybe it's a project, and write some notes about what you were doing. One of the most complicated visualization is the genome browser, integrated with other things, like when you click a position in a spreadsheet, it shows the genome browser shows that one. There we have 4 BAM files, and coverage of those BAM files, so the genes. This is RNA-seq data from ENCODE project, so clearly the gene expression is a lot higher on the first 2. So it's a client-server system. It's distributed. And we have been able to maintain it quite many years already, so it's not totally rubbish. This is the only thing that's in the web browser currently. It's the administration user interface, but it has become quite painful for users to start the user interface, get the Java client running, and that's why we sooner or later we have to move to the web browser, and that's where Bio.js comes along. So quite many of the visualizations are custom made and they are painful to maintain. So I hope that you create great Bio.js components that we can in the following years integrate in our new shiny web client for the Chipster.
All right.
Thank you.
Thanks a lot. Are there any questions?
Maybe how it compares to Galaxy?
Good question. I haven't spent much time with Galaxy, so and I'm a little bit. I think we spend a lot of time with integrating different tools. So the virtual machine package is huge. It's 200 gigabytes, but then you have all the tools there, and it's ready to run. You can just click buttons and focus on the analysis itself, the methods.
Does it have any other input instead of clicking?
Sorry?
Can you write some script?
If you take the virtual machine, then you can freely edit the scripts on the server. Now that we have containers, we don't use them yet, but we could, then I hope that at some point we can allow users to make a lot more code interactive edits. But at the moment, it's only on your own server you can change the scripts.
Okay.